Since I am not here to walk you through an example on ionic bonding, hopefully you'll be watching and listening to this video so that you will already have one example done, and that will help you do the other ones. First of all, you need to get out your periodic table for this. So get out your periodic table, and across the top of most of these families, you need some information which will help you greatly, not only in this worksheet but also in videos 4, 5, and 6 when we get to those videos in class. You're going to need these on your paper. These are called oxidation numbers. Oxidation numbers are the charges that these families have, and it's because of the valence electrons that they have these certain charges. So up at the top of family 1, put a +1. An oxidation number has to have a charge, either a plus or a minus, and it has to have a number. So what this +1 means is that these elements want to give away an electron. Yes, giving away means that you are going to be positive, okay, because you're giving away an electron. Electrons are negative. So if you give away an electron, that means your protons are now bigger, right? Because protons and electrons were equal to each other. But if you give an electron away, what do you have more of? Protons. Protons are positive. All right, so beryllium and magnesium, family 2, they have 2 valence electrons. So they want to get rid of both of their valence electrons, so they have a +2 charge. Now we skipped all of these. We're skipping families 3 through 12. Okay, we're skipping those. So when we get to boron, boron has, and everything in the boron family has 3 valence. That means they want to get rid of 3 valence, so they have a +3 charge. The carbon family is a little tricky. They actually could be a +4 or a -4. You really won't see examples on your ionic worksheet from this family, and that's because they normally share electrons. So you'll see a lot more of those with covalent. Nitrogen has 5 valence electrons, so now we get to the point that in order to bond correctly, they only need 3 more electrons. And so if they could steal 3 electrons from some other element, then they would be happy. So they actually want to gain. Gaining electrons makes you negative. Again, protons and electrons were equal, but if you gain 3 more electrons, now which one's higher? Your electrons are higher by 3, so that's where the negative comes from, because you have more electrons. Oxygen has 6 valence. They want to have 8 valence. That helps them be happy in bonding. So they want to gain 2 electrons. Fluorine, chlorine, bromine, the halogens, they have 7. So they only need 1 more electron, and that makes them a -1. Again, these are oxidation numbers. These have to be on your periodic table. They need to be there. It will help you not only in this worksheet, but like I said, in future videos to come, you absolutely need to know these. All right, moving on to the actual worksheet. Take a look, and you need your periodic table for this anyway. We know how to do parts of this, and I only put the first 2 up here, so you're going to be doing the rest of the chart on your own. If you look up sodium on your periodic table and you look at its atomic number, the atomic number is the number of protons. So we know the atomic number is 11, so we know the proton number is 11. We also know that the protons equal the electrons, and so we still are going to have, if it does this every time, that's annoying, but I'm not sure how to fix that, so we're just going to move forward. So your protons and your electrons are equal, because notice sodium does not have any type of charge right here, so it's neutral, so protons equal electrons. If you look at where sodium is on your periodic table, it's in family 1, so we know that that family has 1 valence electron. And we just put the oxidation numbers on the top of those columns, so we know sodium also has a +1 charge. All right, now moving on to chlorine. That's clear over on the other side. It's in group 17, and it actually has 17 protons. And again, protons are equal to electrons, so that's also 17. The number of valence electrons, if you count over, and this is from the last chapter, we know that they have 7 valence electrons. And we get, again, we just put the oxidation numbers on there. So find chlorine, what family it's in, we had a -1 for the oxidation number. So that's how you're going to fill out the top chart there. You're definitely going to need a periodic table in order to do that. Now, on this worksheet, you have 2 practice problems on the front, and you have 4 practice problems on the back. Okay, we're going to do practice problem number 2 together, and I'm going to walk through what I expect you to have, because you're going to get points for each piece of this. All right, first thing you're going to want to do is take the names of the elements. They tell you which elements you're going to be bonding together, and you need to make a Lewis dot structure for those. So we know magnesium is Mg, and because magnesium is in the second family and it has 2 valence electrons, we're going to put 2 dots on magnesium. Iodine, on the other hand, is the letter I, and it is over in group 17. So it has 7 valence electrons. Again, you're putting the valence electrons around the element, not the total number of electrons. Okay, so those dots are the number of valence electrons. So that's the first step. Do you have the right symbols with the right amount of dots? Now, if you take a look at your 2 elements, your metal is always going to want to give away electrons. Your non-metal is always going to want to take electrons. And you want to think about 8. 8 is kind of a magic number when it comes to bonding, because 8 is how many your noble gases have. They have 8 valence electrons, and they're very unreactive, and that's because they have 8 valence electrons. So if you look at iodine right now, it has 7 valence. Okay, so if it gets 1 more, then it is going to have 8. So if it gets 1 more, then it will have 8 valence, and it will equal a happy element. All right, so it wants 1 more electron. Magnesium wants to give away electrons, and so what we're going to do, because this is ionic bonding, one element gives away electrons, the other element takes electrons. So iodine is going to take one of magnesium's electrons. Okay, don't redraw the electron over here. Okay, just draw the arrow showing where it would go. So iodine still should only have 7 dots around it. Okay, 8 because of that arrow. So this iodine is done. It has 8. We can't put any more electrons around it. Magnesium, on the other hand, still has this electron, and it can't hold on to just one. It has to get rid of both of them. Okay, so we want to put another element into the picture. These are the only 2 elements you're allowed to use. Magnesium and iodine are the only 2 ones you're allowed to have. Because magnesium wants to give away electrons, it doesn't make sense to put another magnesium in this picture, because then we'll just have more electrons to get rid of. Iodine, though, wants to take electrons. So if we put another iodine in this picture with 7 dots around it, then we now have the same problem we did up here. It wants 8. It only has 7. So it can take this other electron from magnesium. And now magnesium has given away both of its electrons, and each iodine has 8 total valence electrons. So in your total answer, you should have the symbols with the dots. You should also have the arrows showing me where the electrons have been moved to. And then you also need to include what the symbols are and their oxidation numbers. Now again, oxidation number has to be a plus or a minus and a number. Because magnesium is losing electrons, it is a plus charge. How many electrons is magnesium losing? On the picture you can see that there are 2 arrows, 2 electrons being given away, so that's a +2 charge. Now for iodine, iodine is not a -2. Okay, if you put -2 here, that means that each iodine has 2 arrows being drawn to it. Okay, so iodine only is taking 1 electron. It's going to gain 1. Now if you want to draw iodine twice to show that, okay, each iodine takes 1, that's okay. But don't put a -2 on the iodine. The last thing you need to include is the formula. The formula tells us how many of each element we have. The positive element should always come first. Okay, so in our picture, this is our picture right here, we only had 1 magnesium. Okay, we don't put ones, so we won't put any number behind there. Okay, your negative element will come second, and so iodine is going to be written. And how many iodines did we have in the picture? We have 1 iodine, 2 iodines total. So we need to have MgI2 in order for us to correctly show how many of each element we have. So all of these pieces here are going to give you points on the worksheet, so don't leave any of them off. Sometimes 1 arrow is fine. If something only has 1 valence electron, it's only going to have 1 item to get rid of. So, you know, there's multiple ways to do this. Different examples have different ways. So if you have questions, please send me an email. Let me know. I will gladly get back with you just as quickly as I can. But the rest of your chart you should have filled out, as well as the rest of your practice problems.